the old design we had for CanBus, and I want to just kind of document this as some information about how to build better APIs and such. And kind of go over how overlapping APIs can actually be quite dangerous and can result in a lot of confusion for the user using it, as well as confusion for the developer trying to implement this interface, and how this could result in a whole bunch of unsafe code. So let's take a look. We have here some settings to set the clock rate for the CanBus. We have a messages that we can receive back and forth. They have an ID, a length, a payload, and this other little field that's not too important. If you don't know what CAN is, it's fine. Don't worry about it. It's actually not the most. You don't really need to understand that for what I'm going to explain. Here we have configure. Configure just lets you take in a settings object and lets you change the clock frequency. Send allows you to send a message based on this stuff here. And then here we have this function called hasData, which returns whether or not there is any data available, and as well as receive, which if there is some data available, this will return an actual object, an actual filled out message object. And then here we have attach interrupt. And ignoring kind of how there might be some other ways to kind of handle this up here, we also have this other attach interrupt, which takes a reference to a CAN object. So basically whatever the CAN object that had this interrupt attached to it will actually pass itself through this function. And that's just so that this particular receive handler can get access to the whole CAN object in order to read the message, make a decision on what it is, its ID, look at some of the data, and then say, hey, with this thing, I need to actually return back a message. It seems like a request message. I need to return back some data. You can do that kind of thing. So that was the kind of the game plan here. Now, what's the problem? Well, there are a couple of issues. I'm going to talk about it first from the user's perspective and problems that come from the user. And then I'm also going to talk about problems that come from the people who are implementing the actual interface. So, a couple things. Number one, if you ever use attach interrupt, what happens to these functions here? hasData and receive. Interrupt should always kind of be able to preempt things. So the moment that there's any data available on that CanBus, in that CanBus peripheral, it's going to launch interrupt and it's going to call your interrupt handler. And there really is no way, to some extent, that hasData will ever return, true to your code, and then also give you enough time to also run receive. And if it ever does happen that way, it's kind of a race condition actually. Just kind of whichever one, you could be midway through receiving that object and cause some other issues. It depends on how those are implemented. But the main thing is that the moment that you have attach interrupt here, this is always going to catch all the different messages. Therefore, these pretty much become useless. So that's one aspect of this particular interface that's kind of flawed, is that the moment you use this, these become dead. Now there's another thing. Let's say that we keep they're still around, and we still have the receive handler, and we're going to actually use hasData and receive in the receive handler. hasData doesn't make any sense in the receive handler because it would not have gotten called if there wasn't something that was available for you to be received. But receive makes sense. Yeah, you're in the receive handler. You have access to the CanBus peripheral. Call receive. That's fine. That actually works just fine. Here's an issue. Most CanBus implementations, peripherals, if you look at any a lot of different data sheets, there is usually either to clear the interrupt, you need to either read the message out of the FIFO, or you need to set a bit which invalidates the FIFO, or at least invalidates one of the items inside the FIFO. Basically, the whole thing is that when you read out data, you destroy it. So it's not really a way to store that for later. This becomes a problem because if whoever writes this handler doesn't actually do the work of clearing the interrupt by running receive, they're stuck in a loop. And they're going to be stuck in that loop forever because that interrupt's going to keep going. Is never going to be cleared, and eventually you'll hit the end of your stack and you'll stack fault in some way. You'll fault in some way. So now this particular interface actually requires that the user fully understand that not calling receive within this function can result in an infinite loop. And if they make one little mistake in some little place in their code, well, now their code's stuck. You may think to yourself, well, that's fine. They need to read the documentation. They understand how to use this thing. And that's kind of okay. But now we have to go to the other side of this problem, the implementer. The implementer now has this particular issue where they actually don't really have full control over how they clear those interrupts. They have to kind of do the clearing of interrupts inside the receive function, which now has this weird kind of splitting of responsibilities. You would think that your interrupt handler routine would actually be the thing to, usually they almost everywhere will clear that interrupt for you. But in this case, well, if you clear it in your receive function, which could actually work, it works. I've done this before. It does work. There's this change of responsibility where like your handler actually never clears your interrupts. It just simply calls your handler and hopes that your handler handles clearing it for you. And this just doesn't seem right. It seems like the responsibility for clearing your interrupt should be in the receive, like not in the receive function, but in the interrupt service routine. And this can actually cause a lot of confusion because if someone doesn't realize that that's how it's supposed to work, they can end up writing code that doesn't clear any interrupts at all, or like clears them in the wrong spot, invalidates data, and now you don't have any like actual real messages. So that's kind of the issue we see here. How can we fix this? Well, we can tell that these three functions overlap with each other. So here's what the new design looks like. The only thing that's changed is that we have removed has data, and we have removed receive, and here we pass a message to the handler. Now all the responsibilities on attach interrupt. Attach interrupt will do the work of setting up the interrupt service routine, setting up its own handler for the service routine, which will then call your receive handler. When the interrupt occurs that says, hey, you've received some data, you simply read out the data. That may clear it for you. If it doesn't, flip a bit, that'll clear it for you after you've read it out, or whatever the condition is. But you should be able to get the data out and then clear your interrupt routine. Then when you have the data out in stack somewhere, you can then pass that to the handler. The handler can do a couple things. It could ignore it, just not care. It could take the data, figure out, and analyze it, go, okay, this is the ID that I need, and like this is some of the payload. Oh, this is a request from this other device. Let me send it some data. It can do that. It could store it somewhere. Put it in a vector, put it inside of an array list, it could put it inside of a circular buffer, it could put it inside of an unordered map, whatever it needs to do. It could put it wherever it needs to do. The main thing here is that like this particular function cannot affect, it has no responsibilities. It can do whatever it likes beyond, actually just breaking the system. But that's, on them. But it's not on them not knowing about how this thing's supposed to work. So with this change, we now have an API that's kind of consistent. You don't have to really worry about if you don't do the right things at the right time, that there will be any particular, that there will result in your system getting deadlocked or hardlocked or whatever. So that's kind of what I wanted to go over, is this idea that you need, whenever you're designing an API, you need to consider the role and responsibilities for your different APIs. They need to not share so much with each other unless it's very, very critical that, that they be separated from each other. That is any overlap, you look to see if there's a way to eliminate that overlap. Otherwise, you'll confuse users as well as implementers. And to think about all the different ways that a particular set of functions can be used with each other, around each other, in order to develop an interface that actually makes sense and is easy to understand when you evaluate the code that's using it, as well as looking at the being able to implement it. One last thing I'll talk about is this idea that I had before, which is actually flawed. Before, I was actually passing in the entire CAN interface so you could run send. Well, keep in mind, I'm using a std function. I'm using the polymorphic function. The reason why I use this is so that you can pass in functors, just basically any type of callable type, specifically lambdas. If you pass in a lambda, well, you can capture your CAN object and then send it that way. Basically, you have full control over how you want to handle that message when it comes in. And that means that you no longer need to pass in your CAN message or your CAN object. You simply need to pass in the data that nothing else in the system could actually know, which is the CAN message itself. So that's pretty much what I wanted to go over. I hope you learned something with this little video. And yeah, I'll talk to you guys later.